Okay, so today we are going to learn about Chapter 1, Physical Quantities and Measurement. So our first subtopic here is 1.1, Dimension of Physical Quantities. So before we look into what is the dimension means, we shall recap at what does physical quantities means here. So we're going to look at what does physical quantities means here. So it is a quantities that can be measured. Physical quantity comes with numerical magnitude and the unit it is measured. For an example, if we have a person standing here, the height of the person, let's say it is 165 centimeter. Okay, this 165 centimeter is known as physical quantities because it has both the magnitude and also the unit that is used to measure. If we only wrote 165 here without the unit, this is not considered as physical quantities because the unit used to measure is not informed here. These physical quantities is divided into two: base quantity and also derived quantity. So base quantity is fundamental quantity that cannot be derived in terms of other quantities, whereas derived quantities are those that can be expressed in terms of basic quantities. We have 7 basic quantities here. We have length, mass, time, electric current, temperature, intensity, and amount of substance. These are our base quantities. Whereas derived quantities, we have quite a lot here because anything that you are going to derive from your basic quantity to produce another new quantities here is considered as a derived quantities, such as area, volume, velocity, force, and etc. We have plenty here. So the next part here is we're going to look at what is the dimension meant here. So dimension is defined as technique or method used to describe a physical quantity in terms of its basic quantity. So for an example, now let us look at 3 common use basic quantity, which is length, mass, and also time. So all these 3 are the basic quantity and we are going to make this quantity into a dimension. How is it made is as you're going to denote the length as bracket, square bracket, capital L and close square bracket. This is what we call as dimension. So this is the dimension for length, the quantity length. So mass is denoted with capital M, a square bracket here, and then time, square bracket, capital T, and this is what we called it as dimension. Dimension can be treated as algebraic quantities through the procedure called a dimensional analysis. Dimensional analysis is a procedure by which the dimensional correctness of an equation can be checked. So kalau kita nak tahu satu equation dimensionally dia betul ataupun tidak, kita akan guna kaedah dimensional analysis. The uses of dimensional analysis are, the first one is to determine the unit of physical quantity, to derive the mathematical expression or equation, and to check the correctness of physical equation by using the principle of homogeneity. So, yang pertama adalah kita nak guna kaedah dimensional analysis ni untuk tentukan unit sesuatu physical quantities. Contohnya kalau kita ada velocity, kita nak tahu apa unit velocity, kita boleh guna dimensional analysis ini. And then second adalah to derive mathematical expression ataupun equation. Maksudnya kita nak create an equation, kita boleh guna dimensional analysis ini untuk tengok equation yang kita create itu betul ataupun tidak. Dan juga to check the correctness of physical equation. Same thing, maksudnya when you have an equation, you want to see whether the equation is right or wrong, kita akan guna kaedah homogeneity dekat sini untuk check that validness of a physical equation. So let's say for an example, kita ada velocity lah. We have velocity and we want to know what is the unit for velocity. Kita nak tentukan apa unit untuk velocity. So kita tahu generally velocity adalah displacement divided by time. So displacement divided by time is your velocity. So to know the unit for velocity, kita akan mendimensionalkan ini. So I'm going to dimension my velocity. Symbol of velocity V, and then displacement, symbol of displacement adalah S divided by symbol of time adalah T dekat sini. Alright, okay, so S dekat sini, displacement is basically a measurement of length. Dia adalah ukuran panjang ataupun jarak kan. So basically it is a length here. So I'm going to use the dimension of basic quantity, iaitu kita punya capital L. And then my T is also capital T here, which is indirectly is LT negative 1. Okay, daripada sini apa yang kita boleh tahu adalah, apa yang kita boleh tahu adalah L is the length and T is the time. Unit untuk length, kita ukur length guna SI unit dia adalah meter. And then SI unit untuk time adalah second. And then you have negative 1 dekat situ, dia jadi negative 1. So this one, MS negative 1 is the SI unit for our velocity. Okay, so this is how you use the dimensional analysis method to determine the unit of a physical quantities. Okay, the table below shows the dimension and unit for some common derived quantities. So let's say if you have acceleration pula, kalau kita ada acceleration dekat sini, kita tahu acceleration adalah velocity divided by time. So kita dimensionkan velocity dibahagi dengan time. Velocity tadi kita dah tahu dia adalah LT negative 1, which is that displacement divided by the time. Then you divide with the time in this equation here. So kita akan dapat LT negative 2. Daripada sini kita tahu L adalah length. So unit dia adalah meter. T adalah time. Unit dia adalah second. So kita pun dapat unit untuk acceleration as ms negative 2. Dan begitu juga untuk contoh kita ambil pressure now. Pressure adalah force divided by area. Force dekat sini adalah mass time acceleration. Okay, naik ke atas sini. This is your dimension for force, which is mass times acceleration. So dia akan jadi MLT negative 2. So this is your MLT negative 2 here. And then divided by the area. Area adalah 2 kali the length. L multiply with the L. So L square dekat sini. So you are going to get ML negative 1 T negative 2. M dekat sini adalah mass. So unit dia adalah kg. And then L dekat sini adalah length. Unit dia adalah meter. And then you have T dekat sini. Unit dia adalah second. So you get the unit for pressure as kg M negative 1 S negative 2. Which is also the Pascal lah. Alright, so kita ada example-example lain. Boleh tengok ada force, ada work dan juga ada power. Boleh go through each to understand better. And then dimensional analysis. An equation in physics is true in any system of unit, SI ataupun British units. A physical quantity is homogeneous if the dimension of all the term in the equation are the same. So dia kata equation kita homogeneous if the dimension in all term of the equation are the same. So kita nak fahamkan benda ni. To check the homogeneity involves checking dimension on the left hand side and also right hand side. Itu yang kita cakap LHS dan juga RHS. Short form untuk left hand side dan juga right hand side. If the left hand side and right hand side are same, the equation is said to be homogeneous ataupun dimensionally consistent. Okay, so kalau kita ada satu equation, basically apa yang ABCD dekat sini tengah cakap adalah if you have an equation and the equation kan selalunya kita akan ada something equals to something. Okay, something equals to something ni, ini yang kita panggil left hand side and right hand side of the equation. So, kalaulah dimension of the left hand side dan juga right hand side yang kita dapat ini sama, maka equation ini adalah equation yang betul. So, kita panggil dia homogeneous. For an example, kita akan tengok kepada kinematic equation kita iaitu S is equals to UT plus half AT square. So, you have S is equals to UT plus half AT square dekat sini. Okay, kita nak check dia homogeneous ataupun tidak. So, the left hand side here, this is your left hand side. This is your left hand side of the equation and this is your right hand side of the equation. So, untuk check dia dimensionally correct ataupun tidak, apa yang kita nak buat dekat sini adalah we are going to do part by part. So, kita ambil dimension on the left dulu. So, the dimension on the left here adalah kita punya displacement. So, on the left dimension on left hand side kita ada displacement dan kita tahu displacement adalah length, betul tak? Length. So dimension dia adalah L dekat sini. This is L. And then kita nak tengok dimension on the right pula sekarang. Dimension on right hand side kita ada UT plus half AT square. Okay, selalunya bila kita nak guna kaedah dimensional analysis ini, apa yang kita akan buat adalah setiap kali kita jumpa any operation such as plus ataupun minus, kalau kita jumpa plus ataupun minus, kita akan split dia kepada dua bahagian. Maksudnya dekat sini kita ada tambah, betul tak? Maka ini akan jadi part 1 of the right hand side equation, ini akan jadi part 2 of the right hand side equation. And kita kena analyse dia part by part. Okay, so kita kena analyse part 1 secara berasingan, part 2 secara berasingan dekat sini. Every time you encounter a plus ataupun a minus, operation of plus dan minus sahaja. Darab kita tak buat apa ya, darab kita buat sekali U darab dengan T, dia masih bersama. Kita akan analyse dia together. So, U dekat sini adalah velocity. So, the dimension of velocity adalah LT negative 1. And then the dimension of time adalah T. So, you're going to end up with LT negative 1 darab dengan T, hilang. So, jadi L sahaja. So, your dimension here now is only L. Alright. And then kita ambil bahagian kedua pula. Bahagian kedua of the equation, you have half AT square. So, half ni, any numerical term yang kita ada dalam kita punya equation, kita akan ignore dia sebab dia has no dimension. Numerical term kita akan ignore. So, 1/2 dekat sini kita boleh abaikan. And then kita akan ambil dimension of acceleration here. Acceleration adalah LT negative 2. And then time pula dekat sini adalah T. And then sebab dia kata square, kalau power you have to consider. Kena consider power dia. So bawa square dia ke belakang sini, letak dekat atas dia. So you have to consider the power, but the numerical term kita boleh ignore sebab dia tak ada dimension. Square kena consider. Any power must consider. So now apa kita ada dekat sini adalah LT negative 2 darab dengan T square. So you're going to end up with L. So as you can see now, your right hand side, part 1 dan part 2 dua-dua mempunyai L. So betul lah kamu ada dimension yang sama. And then your right hand side in general, right hand side kita in general adalah L. Dan juga left hand side kita in general dia adalah L juga. So from here, I can say this equation is homogeneous. Sebab my left hand side is equals to my right hand side. Yang kiri sama dengan yang kanan. So equation ini homogeneous. If the term in an equation have different dimension or different units, then the equation is not homogeneous and the equation is incorrect. Let's say kalaulah kanan saya tak dapat L, maka ini adalah non-homogeneous equation. Two situations when an equation may be dimensionally consistent yet is incorrect are the values of non-dimensional constant in the equation are wrong, the equation is incomplete or contact incorrect term. So kita boleh ada equation di mana the equation may be dimensionally consistent tetapi masih salah. Maksudnya bila kita check left hand side dengan right hand side, kita dapat homogeneous. Tetapi equation itu secara azalinya tak wujud ataupun tak ada. This is because you have non-dimensional constant in the equation which is wrong, ataupun the equation is incomplete lah. Maksudnya memang salah kita yang dapatkan soalan ke atau what so not. The validity of an equation is confirmed by carrying out an experiment to investigate the relationship between the variables in the equation. So apa-apa pun kita kena kaji juga, kita kena do experiment, kita kena buat banyak research and everything to see the validity of any equation. Contoh kalau awak nak invent new equation, tak boleh dah simply guna dimensional analysis tu invent. You still have to do many experiment and also research. Okay, sekarang cuba jawab example 1. Determine whether the following expression are dimensionally correct or not. Okay, remember key dia adalah make sure your left hand side is equals to your right hand side. Ambil dimension on left dulu. Dapatkan apa dimension on left and then on right. Okay, every time you see a plus ataupun minus, split that equation ataupun that part into small parts. Contoh dekat sini kita ada dekat right hand side kita ada 2ut plus half plus at square. So ini akan jadi part 1 of right hand side, ini akan jadi part 2. So kita akan analyse secara berasingan. And every single time you see any numerical term, kita akan ignore the numerical term dekat sini. Power kena consider. Okay, selamat menjawab.